To start using CPCTC and overlapping triangles in this section of notes. It says once triangles have been proven congruent, then all corresponding parts of the triangles are congruent. These corresponding parts can be used to prove parallel lines, angle bisectors, segment bisectors, or other triangles congruent. We can use them for a lot of reasons. In proofs, the statement corresponding parts of congruent triangles are congruent can be abbreviated to CPCTC. Be sure to know what that stands for and when it can be used. This particular statement, CPCTC, is extremely important for us when we are proving things, when we want to use congruent triangles to then go on and say something else. We are going to be using CPCTC in the proof, and we need you guys to remember exactly what that stands for. So please practice knowing what this stands for and being able to write it out. You need to know what these words are and what this abbreviation means. So it stands for corresponding parts of congruent triangles are congruent. And so that's very important for us to understand and use in our proofs. And so we're going to be practicing that today in our notes. So some practice problems here are given below, and it says tell which triangles you can show are congruent in order to prove the statement. Write a congruent statement and list which theorem or postulate you would use. So in this particular one, all we're doing is saying which pair of triangles is congruent, if at all, and how we know that that particular pair of triangles would be considered congruent. So in this first one, notice that this is what we would be trying to prove. So we're going to say how are the triangles congruent, and then we would be able to say this statement, and if we were doing a proof, we would then say by CPCTC. But here we're just again practicing why are the triangles congruent. These triangles are touching. They share a side. That side AC is the shared side. They have matching markings in both triangles. A lot of people see a right angle and think it's immediately hypotenuse leg. This is not hypotenuse leg. The hypotenuse is not marked in either triangle. It has two sides marked in the angle that's in between, so this is side angle side for the reason, but I'm going to name my triangles, so I'm going to say triangle ABC congruent to, I started at A, which was the right angle, went to B, then I went to C. Remember, you've got to repeat that order. So C is the right angle over here. I went to B across the side with one marking. So from C across the side with one marking to D, and then over to A, to name them in corresponding order. And my reason, so by side angle side congruence postulate. The second one here, they already marked the shared side, and they have these angles marked. So we have two angles in each one marked, and then a side, and the side is not the included side. The included side would be like side TU. So the reason is going to be angle, angle, side, congruence theorem, but we do need to name our triangles again. So I'm going to say TUS. The first one doesn't matter, the order. It's the second one that matters. So I started with the one marking, then the right angle, then no marking. So the one marking is V, the right angle is U, and then the no marking again with S. And the reason for that one is angle, angle, side, congruence theorem, because we have the two angles and the side that's not between them. The third one here, they share a side. I'm going to mark that. All the sides are marked in both sets, on both triangles, both sets of sides marked, so I'm going to name them. I'm going to call this one ABD, congruent to triangle. A was between the one marked side and the two marked side, so I've got to go between the one and the two marked side and start at C. I went from A across the two marking side to B, so I need to go from C across the two marking side to D, and then to B. Again, be very careful of the order. It's very important that you get it in the right order. And that's by the side, side, side congruence postulate. The next ones that explain how you would prove PR, segment PR congruent to QS. In this picture, we've got some overlapping triangles, and I've tried to make them where we can separate them and see them. I've got this triangle that goes from P to S to R, and I've got a triangle that goes from S to R to Q. Inside of there, I didn't add these little tick marks on there because they're not really part of those triangles, but I do want to talk about what that's going to do, kind of strategize before I get into my proof here. If these pieces are congruent, notice that you have a little bitty isosceles triangle. And by the isosceles triangle theorem, you can say that these little base angles are congruent. And since I've already got one arc, I'm going to use two arcs there. So angle R in this red triangle and angle S in this blue triangle, which is where those came from, are also going to be marked congruent. And with your overlapping triangles, they also hide shared information like a shared angle or a shared side. These particular triangles share the side from S to R. So segment SR in each of these is an overlapping piece, and they both have that, so you can mark that congruent. So I can tell that these triangles are going to be congruent by angle, angle, side, and then I can use CPCTC to prove PR congruent to QS. So now I'm just going to get that all into a proof for us. So I'm going to set up my T chart here. Probably need to move this over some. And get my proof going. So I had some given information at the beginning. The given information that I had was that ST was congruent to RT. And I'm going to use that right now, so I'm going to say given. And I had other stuff given, just these angles up here, but I'm not going to write them down yet because I like to, if I'm using this given, I like to write how I'm using it right below it. So I'm going to use this given to say that angle QSR is congruent to angle PRS, and that was the isosceles triangle theorem that says if we've got the congruent sides in this triangle that the base angles will be congruent. And so now I've got that part. The other given was that angle SPR was congruent to angle RQS. That was given. So now we've got the two angles in the proof. Make sure that you get everything that you had thought about using into your proof before you're done. Then we had also this shared side, SR. So we're going to say SR is congruent to SR by the reflexive property of congruence there. And those were the three pieces that we were going to use to prove the triangle's congruent. So now we have to name them. And again, when we're naming them ourselves, be very careful of the order. I'm going to say PSR, that one I just picked. So it started at P with one arcing, went to S that has none, went to R with two. So I'm going to start at Q with one marking, go to R with none, and then to S, which has two marks in the blue triangle. And so my reason there is angle, angle, side, because the side is not between the angles, and I have two angles on a side, so I'm going to say angle, angle, side, congruence theorem. And now that the triangles are congruent, we can show that PR, which is a piece of the red triangle, and QS, a piece of the blue triangle here, are congruent to each other by CPCTC, meaning congruent. Corresponding parts of congruent triangles are congruent. Definitely practice saying what that means. It's hard to talk and write, sorry. PRQS, CPCTC, corresponding parts, congruent triangles are congruent. I'm going to do one more proof in this video and then break for the next video. Right here, I have another proof going, and they have these statements here, and we're just going to fill in the reasons. And again, it's got some overlapping, a bunch of triangles in this picture, and it gets a little bit confusing, and so I've drawn the triangles separately for us to help us visualize what's going on here. Currently I had the orange, which had just this marking on XY, and the purple, which had XW. Do notice that they shared the segment in the middle. So I'm going to use reflexive property to prove that piece congruent. And then they also gave us a vocabulary word that has not been marked yet, and that's that angle bisector. So first I've got my given statement, which is that yx is congruent to wx, and that's already marked. And we'll just put given there. Zx bisects angle yxw. So find yxw is the top angle there, and so that angle is being bisected, so we can mark this piece at x and this piece over here at x congruent to each other, and the reason is definition of an angle bisector. And then, oh wait, that wasn't the reason for that line. That was the reason on the next line. Got ahead of myself. That was a given statement. So this was our second given. See, we all mess up. The reason the angles are congruent, that is the definition of an angle bisector. There we go. All right, and I had mentioned that they share that side in the middle at XC. Each of them has that same piece. It was overlapping when they were here in this picture together, and so that's the reflexive property of congruence there, because they're congruent. And now that we're looking at these, especially when we look at them drawn separate from each other, you can see that you have two sides and the angle that's in the middle. So it's going to be side angle side, congruence postulate for the reason for those triangles being congruent, and then CPCTC, using the congruent triangles to show that these pieces from Y to Z and from W to Z are congruent because they're corresponding. Corresponding parts, congruent triangles are congruent.